Hey guys, so this is the last part of section 4.5, so I'm on page 396, and now it's everybody's favorite, clearing fractions and decimals. So I actually think though that this should be something, this is a good review if you forgot, but this is something that we should already be kind of familiar with. So I have now, you can see with this system, so I have a bunch of fractions in it, and so what you're going to do is you're actually going to clear the fractions per equation. So what I mean is, for this one, what is just the LCD of just this equation? So you've got the denominators 6, 3, and 2. So the LCD here would be just 6. Okay, so let's just focus on that one to start. So what I want to do then is I want to multiply each fraction by 6. And this is very similar to the technique that we discussed a little while ago. So let me first write this all out. Equals, let's see, I've got 6 times 1/2. Okay, so I set all that up, right? And then I go through each part and I just divide the denominator into this number, into the LCD. So for instance, 6 divides into 6 once, so I'm going to cancel these out. And so this will just leave me with 1 times 1x. So this will become just x, right? Then if I move on to the next part, so 3 goes into 6 twice. So this will leave me with 2 times 1y. So I'll subtract that off, so this becomes minus 2y. And then finally, 2 goes into 6 3 times. And then I'm just left with 3 times 1, so this whole thing will just equal 3. So here's one equation. So what I'm going to do, I'm actually going to put this little box around it so I don't lose it, so I can reference it later, because we're going to obviously need to stack these up in a second. Okay, so that's the first one. So now let's look at the second equation. So this one I made it nice and straightforward, so you can just see the LCD here is 5. So let's set that up. So here my LCD is 5. So I want to do the same thing. I want to cancel out all the fractions. So I'm going to set up 5 times each fraction minus okay, so there we go. Everything's set up. And this time, now it's like very quick, right? Because 5 just goes into all of these. So like 5 goes into 5 once. So when I multiply this together, 1 times 2x, this will just be 2x. And then, let's see, 5 goes into 5 once. So this will leave me with 3y. And then the 5's cancel out. So then I'm just left with negative 6. So I drew these little boxes around what I'm left with because this is what I actually have to work on, right? So we're not even, that was just clearing fractions. So don't forget the goal of this. So now I take these two simplified equations. Let's see, I'll give myself a little space here. Take these two simplified equations. And so now I actually just solve this as usual. So you can see I still have to use elimination here. But here's the good news. So as far as like moving forward with the problem, you can just use these equations. You don't have to refer back to these. So let's say that I want to multiply this top equation by negative 2. So let's see, I'll note that. Maybe I'll note that here. So multiply by negative 2. So let's rewrite this system then. The top equation would become negative 2x plus 4y equals negative 6. And then the bottom one is going to be unchanged. Okay, so if this is what I'm working with, so if I go ahead now and add them all together, this will be y equals negative 12. Okay, so here's why I kind of wanted to work through all this with you. So now, like, you might be thinking, oh my god, I have to plug it back into this crazy thing, and you don't. You can just plug it back into one of these two equations here, and I'll plug it back into the first equation. So let's take x minus, I've got this x minus 2y equals 3. So this is what I'm going to plug my negative 12 into, like this. And so I get x plus 24 equals 3. Subtract off the 24. So I get x equals negative 21. So this has kind of become a little bit of a mess. But my solution in this case will be negative 21 over negative 12. And I think this actually illustrates a really great point here. So what you are going to want to do, you're going to want someplace to do all the work on kind of like cleaning up your system, and then you want someplace nice to work on your system. So however you want to set that up is kind of up to you. And maybe you want to like use the top part of a piece of paper. I'm a little bit limited by space here. But when you're working on these in my math lab or whatever, I would recommend, trying to give yourself lots of space so that you can kind of spread out and put all this detail in. Okay, so for this other one, I just wanted to remind you of what do we do with clearing decimals. So notice the second equation doesn't have decimals, it's just the first equation. So with this one, what I want to do is I want to count the maximum number of decimal spots, and that's 2. So I'm going to move all of these decimals, so I'll just kind of draw it here. I move each decimal 2 spots. So the top equation then will become 2x plus 10y equals 5. And then I've still got the bottom equation, right? And so now what I've got to do is I've got to multiply one of them by something. So I'll multiply the top equation. I'll multiply this by -2. And by the way, I would recommend, like, as you're doing this, try to write these types of notes to yourself, just so that you can kind of track your work. And if you ever have to backtrack, you can kind of read it and remember, oh, that's right, I was trying to multiply by -2. It just keeps yourself organized. So let's see, I'm multiplying this top equation by -2, and then I've got the bottom equation. So now you can see what's going to happen here, right? So if I multiply, or if I add everything together now, I get 0 equals 0. So this one's actually infinite solutions. So if you totally forgot how all of that works, just a reminder, it's pages 246 and 247. So this is where you can go for a review. So you can double back. That was from chapter 3, and that was in section, let me look. That was from section 3.2. So if you want to watch the whole review of kind of how to do that, you can just backtrack and watch that video. So it's kind of the nice thing about having all these videos. So now what I want you to do is I just want you to try these two just to make sure that you're good. So clear the fractions and everything. So try both of them, hit play when you're ready. Okay, so I'm going to try to just be a little more neat this time when I set this up. So starting with this first equation here, so just notice that the LCD here is 4. So I will just set that up, just the multiplication. Okay, so here it is, and so I'm going to first say, so 2 divides into 4 twice, so I'm left with 2 times -x. So this first part, this will be -2x. And then this next part, so 4 goes into 4 once, so this is 1 times 3y, so this will be -3y, and then this will equal 4. So there's my first equation. I will put a little box around it so I don't lose it. So now let's go to the next one. So for this other one, so let's see, I'll use maybe purple here. So the LCD of this one is 6. So once again, I will set that all up. Okay, so there's my setup. So let's go through and cancel stuff out now. So 3 goes into 6 twice. So I'm left with 2 times x. So this is 2x. And then 2 goes into 6 3 times. So I'm left with 3 times 3y. So this is plus 9y. And then 3 goes into 6 twice. So 2 times -2, this will give me -4. So there you go. So there are my 2 equations. So now I've got some more space over here, so I'll stack them up together. So this is -2x minus 3y equals 4, and 2x plus 9y equals -4, which is awesome, right? Because now the 2's will just drop out, so we can just go ahead and add straight down. So this is 6y equals 0. Divide both sides by 6, I get y equals 0. Now I just have to solve for the other one. And remember, you can plug this back into one of the nicer looking equations. So this will be negative 2x minus 3 times 0 equals 4. So that's negative 2x equals 4. Divide each side by negative 2, and I get x equals negative 2. So I'll just write my solution here. I did a much better job of managing my space this time. So it's negative 2, 0. Okay, so we had that one. And now let's go to the other one. Okay, so for both equations, I have to move all the decimals twice. So remember, when you move this decimal, you're going to move it twice, move it twice, move it twice, fill in the empty spots with zeros. So the top part will be 10x minus 5y equals 20, and the bottom will be 30x minus 25y also equals 20. And so now you can see from looking at this that you're going to have to multiply one of these by something. Doesn't matter which one you want to multiply. Maybe you multiply by 5, or maybe you multiply by 3. I just like 3 because it's a smaller number, so I'm going to multiply this by negative 3. So the top equation will become negative 30x plus 15y equals negative 60, and then the bottom one is going to be unchanged. Minus 25 equals 20. Okay, so if I add them together, now I get negative 10y equals negative 40. Divide both sides by negative 10, I get y equals 4. And now I'm going to plug this back into one of the nicer equations, so I'll plug it back into the top one. So this will become 10x minus 5 times 4 equals 20. So that's 10x minus 20 equals 20. Add 20 to both sides, so I get 10x equals 40. Divide both sides by 10, and I get x equals 4. So now I'll just write my solution. My solution here is 4, 4. Okay, so last page. So Davin wants to have some t-shirts printed for his school club, and he got quotes for t-shirts from the 2 companies below. So we've got the Shirt Factory, where it costs $5 to print each shirt after the initial $50 fee, and then we have Custom T-Shirts Are Us, and it costs $10 for each t-shirt after the initial $20 fee. So now I want to write 2 equations just to model the pricing structure. So for the Shirt Factory, so we'll let this be y equals. So it's that $50 initial fee, and then it's $5 per shirt. So I'll call that 5x. Then for Custom T-Shirts Are Us, so this will be y equals, so it's the initial $20 fee, and then $10 per shirt. So now this is what I want to actually solve. Now, you might notice that this is not set up like the other equations. So if you ever want to manipulate these to make them work for you, you can always do that, right? So what I could do, for instance, is I could subtract off the 5x here to turn this into the equation negative 5x plus y equals 50. And I can do the same thing here. Subtract off the 10x so that I get negative 10x plus y equals 20. So now I'll take those 2 and I'll just stack them next to each other. And I actually like that because then I can really clearly see what I have to do here. So I just have to multiply one of these really by negative 1. So I'll just multiply this one by negative 1. So this becomes, so I'm going to restate the system again. So I always like to restate the whole thing. So this becomes 5x minus y equals negative 50, and then negative 10x plus y equals 20. Oops, yeah, those are right. Okay, and that's negative 5x. Okay, I knew I missed it. No, I got it right, sorry. Okay, so now if I add everything together, this will be negative 5x equals negative 30. Okay, now I'm on the right path. Okay, so now if I divide both sides by negative 5, I will get that x equals 6. And then I plug that into either one of the equations, so I'll plug that into the first one. So we'll call this -5 times 6 plus y equals 50. So that's -30 plus y equals 50. Add the 30, and I get y equals 80. Okay, so now remember you have to, this is an application, so you want to just read what the question was. So it's what amount of shirts does it cost to print the same amount at either company? So what this means is that at 6, this is 6 shirts, it will cost $80. So you want to just make sure you understand what all of those mean when you go back. Now, the last question here's, the last two questions really, have to now do with where is the better deal for printing? So if the school has 4 members, where is the better deal to print shirts? So now I have to actually just compare this to the two different pricing structures. So if I have 4 members, so if I compare these, so remember my equations were y equals 50x plus 5x, that was the first company, versus y equals 20 plus 10x. So you can probably tell just by looking at this which one it works, which one is cheaper, but we'll just compare them both. So I'm going to plug in 4 shirts. So if I work this out, this first company, it will cost 70 versus at the second company, so this is 20 plus 10 times 4. So this will come out to 60. So this was the second company, so this would be the, what is it, Custom T-Shirts or Us. So this tells me Custom T-Shirts is cheaper. And then if I do that one more time for 15 members, so I'll just plug in those numbers now. So I have 50 plus 5 times 15. This will come out to 125 versus if I use the other company, so 20 plus 10 times 15, this comes out to 170. So at 4 members, Custom T-Shirts was cheaper, but now at 15 members, the first company was cheaper. The first company was called the Shirt Factory. So this tells me then the Shirt Factory is cheaper. So we have at 4 members, it's cheaper to use Custom T-Shirts or Us. At 15 members, the Shirt Factory is cheaper. And then at 6 shirts, it cost the same amount. Yeah, it costs the same amount. Okay, so that wraps up this section. So thanks for watching. We only have 3 more sections to go, so you guys are getting pretty close to being done with the class. That's pretty exciting. So I'll see you guys next time.